All right, CNBT 1311, we are back. Fourth video in chapter 12 on plastics. Yes, we live in a plastic world. Plastic fantastic lover. All that good stuff, right? Okay. Plastics are of any of the numerous synthetic or natural organic materials. Mostly they're thermoplastic or thermosetting. Polymers of high molecular weight that can be molded, extruded, drawn into objects. Films and filaments as a class of plastics are tough, resilient, lightweight, resistant to corrosion and moisture. All right, that's what they say. Many plastics also emit gases that are harmful to the respiratory system and it releases toxic fumes when burned. One of the foundations of many plastics is cyanide. So when you burn it, you have a cyanocyanic gas that is coming off. Um, the ammonium, the cyanide tank that was out in DuPont in Victoria has about, I'd say 300 feet in all directions around it. It sits by itself in a gravel yard. At least it did when I was doing work for them through Fleur Daniel years ago. While there are many types of plastics, thermonomers or polymers, they range in characteristics. The bottom line is the only thing you need to understand right now is you have thermosetting plastics and you have thermoplastics. Okay? Thermosetting, they go through a pliable stage. There's a chemical reaction with the hardener and the resin, but once they are set or cured, they become permanently rigid and cannot be softened again by reheating, aka recycled. We go back to the wind turbine blades. Okay? All right. Thermoplastics are capable of softening or fusing when heated. That's how those orange gas, natural gas lines are connected. They have a heater and they just melt the plastic into the pipes and they squish it together and they have a fused welded joint. You can weld thermoplastics. I have a plastic welder. Um, it's how I repaired the high density polyethylene fishing kayak that I had. Um, um, you take that heat gun welder and take a rod of the HDPE and you just weld it like you would steel. Um, well, anyway, thermoplastics are capable of softening or fusing when heated without a change in any inherent properties and of hardening again when cooled. Thus, these can be recycled. You can grind them up into little bitty pellets, you heat it up, you repelletize it, and you extrude it. The largest profit margin of any of the oil companies in their refineries is thermoplastics, plastics and chemicals. Um, Gasoline, diesel, and oil is just a small byproduct of that process. All right, in the table listed below, so we want to concentrate on thermoset and thermoplastics. So in the table below, the commonly used. Okay, so these are your thermosetting plastics. Thermosetting plastics. Once they're cured, they're hard, and you're not going to reshape them. Okay, epoxies, melamines, phenolics, polyesters, polystyrenes, and silicones. The uses: adhesives and surface coatings. Well, of course, epoxies. High pressure laminates. Those are your melamines, formica, that sort of thing. Electrical parts, phenolics, uh, foam insulation, adhesive coatings, fiberglass reinforced plastics or polyesters, polystyrenes, foam insulation, sealants, adhesives, and coatings, and silicons, waterproofing, lubricants, adhesives, and synthetic rubber. Okay. Your thermoplastics. Now remember, thermoplastics can be heated and reshaped and then recycled very, very easily. Very easily. Okay. Very easily. Um, ABS. Okay. Uh, PMMA. These are acrylics. CAB, cellulose acetate butyrate. Nylons, polycarbonates, polyethylene, polypropylene, polystyrene, and vinyls. PVC, polyvinyl chloride. Okay, polyvinyl chloride. All right, and you have ABS piping, you got PVC piping. You got to use different glues on them. Now they do make a glue that'll work with ABS piping and PVC. My advice, and in my experience, it's best to get a purpose-built glue for ABS and a purpose-built glue for PVC. Now, if you got an old house and they used ABS, like in mine, and you're putting in PVC to it, then you've got to use that combo, the combo adhesive, so that you get a good joint. All right, pipe and pipe fittings, indoor hardware. What's acrylics used for? Well, here is the use for them. Acrylics are used in adhesive, caulking, and latex paints, and glazing. Pipe and pipe fitting, all right. Synthetic fibers and filaments, nylons, safety glazing, lighting fixtures and hardware, polycarbonates, including some of your ballistic plastics, damp proofing, vapor retarder, polyethylene, and electrical insulation. Polypropylene, pipe fittings, electrical insulation, and carpeting fibers, polypropylene. Polystyrene, lighting fixtures and foam insulation. All right, polyvinyl chlorides, PVC, flooring, siding, gutters, window frames, insulation, and piping. All right, plastics. We're not going to talk a lot about glass. Glass is a hard, brittle, chemically inert substance produced by fusing silica together with a flux and a stabilizer into a mass that cools to a rigid condition without crystallization. That way you can look through it, see through it, right? It's used in building constructions in various forms. All right. Foamed or cellular glass is used as rigid, vapor-proof thermal insulation, such as fiberglass insulation, right? All right. There are three major types of flat glass. You got sheet glass, plate glass, and you got float glass. All right. Float glass is manufactured by pouring molten glass onto a surface of molten tin and allowing it to cool slowly. The resulting flat, parallel surfaces minimize distortion and eliminate the need for grinding and polishing. Float glass is a successor to plate glass and accounts for the majority of flat glass production. Okay, plate glass is formed by rolling molten glass into a plate that is subsequently ground and polished after cooling. So plate glass provides a virtually clear, undistorted vision. And then sheet glass is fabricated by drawing the molten glass from a furnace. That's called drawn glass. Or by forming a cylinder, dividing it lengthwise and flattening it. That's cylinder glass. The fire polished surfaces are not perfectly parallel, resulting in some distortion of vision. To minimize this distortion, glass should be glazed with the wave distortion running horizontally. So, there's your actually three major types of glass, and then with drawn glass and cylinder glass under sheet glass. All right, insulating glass is just that. It's two sheets filled with argon or air, or a mixture of argon and some other gas. Tinted, all right, so that's insulated. Tinted or heat-absorbing glass, we've talked about this before. They have a chemical admixture, absorbs a portion of the radiant heat. Reflective glass has got a thin translucent coating that reflects off of it. And then you have low emissivity, low E glass, which transmits visible light while selectively reflecting the longer wavelengths of radiant heat. Your high-end insulated glass panels will come with an option of these different coatings to give you a different effect. All right. Single pane glass transmits a lot of noise. Depending on how your insulated glass is done, it transmits less noise. Okay. Now there are other types of glass, and that includes anneal glass, which is cooled slowly to relieve the internal stresses. You got heat strength glass. It's anneal glass that is partially tempered by a process of reheating and suddenly cooling. Heat strength glass has about twice the strength of anneal glass of the same thickness. Tempered glass. It's anneal glass that's reheated to just below the softening point and then rapidly cooled to induce compressive stresses in the surface and edges, and tensile stresses in the interior. Tempered glass has 3 to 5 times the resistance of anneal glass, okay, to impact and thermal stresses, but it cannot be altered after fabrication. When fractured, it breaks into relatively harmless pebble-sized particles. That's tempered. It's got a lot of stress in it. That's the kind of glass that's in your automobile, okay, or in high occupancy storefronts and stuff like that. All right, it's tempered. They used to call it safety glass because it breaks into the small little pebbles that are relatively harmless. All right, the pebbles will still cut you. All right, laminated or safety glass, all right, is tempered glass, but it's got a sheet in between it. Okay, it's so they used to call all tempered glass safety glass. Laminated or safety glass, 2 or more plies of flat glass bonded under heat and pressure to inner layers of polyvinyl butyl resin that retains the fragments if the glass is broken. Security glass is laminated glass that has exceptional tensile and impact strength. All right. Wired glass is just that. It's flat or patterned glass having a square diamond wire mesh to prevent shattering in the event of breakage or excessive heat. Wired glass is considered a safety glazing material and may be used to glaze fire doors and windows. Patterned glass has a linear geometric surface pattern formed in the rolling process. So don't get laminated safety glass and tempered glass mixed up. If you need safety glass, you need to specify safety glass and the exact strength of that safety glass. Okay, a lot of people still refer to tempered glass as safety glass, and it's not. Okay, you have laminated glass. I misspoke up here about tempered glass. It is tempered, but it is laminated in your automobile. All right. Wire glass is flat or patterned glass, and we've already talked about that. Obscure glass has 1 or more sides that are acid etched or sandblasted to obscure vision. Either process weakens the glass and makes it difficult to clean. Well, obviously, because it's got a rough surface on it. Spandrel glass is an opaque glass for concealing the structural elements in curtain wall construction, produced by fusing a ceramic frit to the interior surface of tempered or heat strength glass. All right. One thing to remember, all glass panels have an Achilles heel, and it's at the edges. It's at the edges. Find that edge, and you'll shatter that glass. That's the Achilles heel of all of them. Glass product. All right. And this whole thing talks about the varying maximum sizes of any glass, the reflective coatings. You can read this to your heart's content. Okay. Nominal thickness, maximum area. Your mileage is going to vary with maximum area. You get with your glass people, because they'll be able to tell you what you can and can't do with it. Okay. All right. Insulating glass. Again, your mileage is going to vary. You get with that manufacturer of that insulating glass, and you figure out what your R values are. Of course, your mechanical engineer is going to be getting with you early on to figure out the heat load and heat gain of that building based on your glazing, your glass. All right, and solar energy transmission reduced, visible light transmission reduced. So look at this. Your mileage is going to vary. Get with your glass, people. Nails, fasteners, nails. I think this thing ends in, yeah, this thing ends on page 22, if I'm not mistaken. All right. Oh my God. Now, in the ancient days of yore, they used to refer to the sizes of nails as D. I mean, they did. They're like a 10 penny, an 8 penny, a 6 penny, or 4 penny nail. All right. But it's in D sizes. Okay. Nails are straight, slender pieces. Material are usually mild steel, but may also be of aluminum, copper, brass, zinc, or stainless steel. If you're doing boat building, you're going to want stainless steel staples and stainless steel nails. Of martinistic, not ferritic stainless. Ferritic stainless will rust. You can get them tempered. High carbon steel nails for greater strength, like for driving in masonry or concrete. The type of metal used should be compatible with the materials being secured to avoid loss of holding power and prevent the staining of the materials. In other words, if you're doing a lot of exterior stuff, you're going to want these galvanized or coated. All right. Okay. So 20D nail is 4 inches long, roughly. Your typical framing nail is a 16. That's 3.5. And it goes all the way down to a 4D. All right. So these are common nails for general construction. Box nails. They call it a box nail because they're kind of thin. They're like a casing nail or a finish nail, but they got a head on them, and it's for building boxes and crates and stuff like that. Okay. Nail lengths are designed by the term penny. I told you 10 penny, 8 penny, 4 penny. So that's D. Nails range in length from 2D to a 60D, which is about 6 inches long. Those are bridge timber nails. I drove a lot of those with that project in College Station where they had that big heavy timbers supporting the walkway covers around that shopping mall. Rule of thumb, the nail length should be about 3 times the thickness of the material being secured. Large diameter nails are used for heavy work, while lighter nails are used for finish work, and thinner nails are used for hardwood rather than softwood. Depending on what hardwood you're driving the nail through, if you're not using like a floor nailer, you'll need to pre-drill that hole. And the best thing to do is just go ahead and whatever nail you're using, cut the head off of it, put that in the drill, and use that nail to kind of pre-drill the hole, and then take the nail and drive it on through. You'll reduce your splitting greatly. Let's see. Here we go. All right. So this is a box nail. This is a casing nail. Some people get these mixed up between finish nail and casing nails. A finish nail is not a casing nail. You can use casing nails and finish nails interchangeably, depending on what kind of trim work you're doing. The casing nail has a bugled head on it, so you can come in with a nail punch, which is a chisel looking thing. It's a punch, and they come in various sizes. Oh, that's ugly. That's an ugly deal. Anyway, and you drive that down flush with the your casing work or your trim work, and then you take that punch and then set it on that nail head and countersink it a little bit so you can put the painter's putty on it and then sand it and paint it. Same with a finish nail. It's got a little different head on it. Flooring nails. We talked about nailing flooring. This is this is if you're doing it by hand. Oh my God! If you're going to do wood flooring, you need to go get you a floor nailer, like I showed you in that video. Okay. Try to blind nail this thing. bust your fingers all up with your hammer. And you certainly don't want to face nail your flooring, because these nails will have a tendency to walk out. And you'll have little nail heads eventually sticking out of your flooring, and it'll look ugly. All right. These are cut nails. These are flat. They're almost like a horseshoe nail. And these are also for flooring. You'll see some of these in clips, depending on the manufacturer of the floor nailer. And they'll have a little bit of glue in between them, or on a paper strip, and they'll be in the magazine coming out the back of the floor nailer. All right, roofing nails, they got a large head on them, and roofing nails can be aluminum, they can be steel, galvanized, and they come in different lengths too, depending on how thick you're having to go through on your roof. All right, but a cut nail is just like that. Okay, it's going to it'll have a head on it. It'll have a head on it. If you're looking at it from the side, and it'll be tapered. It'll be tapered, and it'll be flat. Okay, it'll be flat, just like this. And Ching did a better job of drawing than I did. All right. Okay. All right. This is a duplex nail. This is a duplex nail, or a double-headed nail. This is for forming, concrete forming. If this is the wood form, or the whaler or the well or the form, that'd be like a piece of wood. It's holding the form up away, and this might be your plywood form board coming down through here. Okay. Then what that does is allows you to drive these in tight against the wood, just like a regular nail. And when the concrete sets and you're ready to erect the forms, you have a head that you can come in here with your crowbar, your wrecking bar, and yank the nails out. Yank the nail out of the form. Of course, this is not going to go into concrete. This is way not to scale, right? So that lets you pull the nail back out. That's a duplex nail or a double-headed nail. Okay. And he says that over here. All right. The form of the shank for greater gripping strength. Nail shafts may be serrated, barbed, threaded, fluted, or twisted. Nail shafts may be cement coated for greater resistance to withdrawal, or be zinc coated for corrosion resistance. One thing you can be assured of, if that structure is moving or you got vibration in it, the nails will start walking out, period. So you might want to use ring shank nails, and that's what he's talking about over here. They may be serrated, barbed, or whatever. And then the nail heads. We've got flat heads, the heads for finished nails, and then you got double-headed nails, and he does mention concrete formwork. Nail points. Most nail points have a diamond-shaped point. Sharp-pointed nails have greater holding strength, but may tend to split some woods. Blunt points should be used for easily split woods. All right. So, but if you're nailing in super hard woods that have a tendency, like oak, which has a tendency to split, again, the best thing is to pre-drill the hole. You can use a smaller nail, get you a finished nail, and pre-drill that hole, and it will help with the splitting. Power-driven fasteners don't split as bad as hand-driven. Masonry nails, good luck. This is what masonry nails are super hard. They're tempered. They're hard nails. You need to be wearing safety glasses. And they're for hammering into concrete or masonry. It's a whole lot easier to drive these into the grout lines than into the brick. or the concrete. Best thing to do is get these started into the sill plate and get you a big mallet. They do tend to break because they're brittle. Easiest thing for nailing into concrete is use a power-driven fastener, like a Hilti gun. I've got power-driven fastener. It uses a 22 cartridge, 22 blank, rimfire blank, and it's a power-driven fastener. And it'll drive a special. It's not one that look like this. It's specially designed, power-driven. It's super hard material, and it'll go down through that concrete. The problem with power-driven fasteners in the concrete, though, is sometimes that concrete will spoil. It'll blow out. Let's just say you're trying to nail down a seal plate. And so you put that gun down here. There's a trigger. You pull that trigger, and that 22 blank drives that nail down through here. Sometimes you have it has a tendency to break concrete out in a cone-like fashion, and you got less grip on. So it depends on how old and how hard that concrete is. These do have their place and their purposes. Sometimes you got to shoot them twice. The head will be sticking up, then you put another cartridge in there and set it back down on there and fire again. Let's see, spikes are for heavy timber, and power-driven studs for driving into concrete or steel. I have found the best thing to do for concrete is to get a rotohammer bit. Go ahead and set your seal plate. And if you've missed an embedded anchor, you can drill down through this concrete with a rotohammer and put either an expansion anchor, or the best thing is an all-thread rod, and you fill this hole with a Sega epoxy caulk. Sega makes a special epoxy bolt setting compound that adheres to concrete. You got to blow out all concrete dust, make sure it's clean, and set that all-thread rod or bolt in there. And then you can come back with a washer and a nut and tighten that puppy down. Building codes are going to want these base plates bolted. This nailing is for temporary stuff, and I don't know of any building code that allow this to be your standard base plate attachment to concrete. Best thing to do is to cast in them J-bolts with your concrete formwork with your slab. Here's your finished slab, and you get these are not on 16-inch centers. You got to start off, you have to offset them so they're in between the studs, and then you drill that base plate and you set that over here, and you put the washer and the nut on it and an impact wrench that sucker down. Anyway, enough of that. Power-driven fasteners are pneumatic nailers and staplers driven by a compressor, and they're capable of fastening materials to wood, steel, or concrete. Now, for heavy steel, I don't know of any air-driven fastener that's good for that. Hilti uses a power-driven, which uses a 22. That's a power-driven. They use gunpowder charges to drive a variety of nails and stud in concrete or steel. If you're going through concrete and steel, this is the best way to go. Power-driven fastener. Man, I've shot a lot of stuff. You get a good engineered system like Hilti, and the powder charges come in varying levels. So if you've got a structural steel perimeter beam wide flange, and you're coming up with platform framing. You're going to fill this in, the spaces between the columns with wood studs. Then you've got a metal base plate, a wood seal plate, base plate, seal plate, and you take that Hilti gun and it will drive that nail flush into that through that wide flange. And we did a lot of this on the weirdo shopping center I did back in the late 70s in College Station. What we did was we pre-built the walls, pre-framed them, and then lifted them up with the crane and set them in the base like a curtain wall, but it set it on here, and got our dimensions good with the top beam, and slid that in, and then came through and shot this through that beam, and then shot it on top. We had another one just like this. This whole wall runs up, and we had a beam up here, wide flange, and seal plate, top, and shim that in tight, and then we shot that also in between those studs. All right. Okay. Screws and bolts. Where are we at on time? I think 22 is the end of this chapter. Yeah, it is. We'll get through this. Screws come in various shapes, sizes, strengths, and usages. They got different heads. This is your typical wood screw. This is a drywall screw. This is a machine screw. This is a self-tapping screw. And just because it says self-tapping, don't think you don't have to pre-drill that hole. This is a sheet metal screw for going through light sheet metal. This is a cap screw, and this is a set screw. All right. Flat head, oval head, round head, truss head, pan head, Philister head, bugle head, and a security head. You go into a commercial bathroom or restroom, and you look at how the stalls are put together. You'll see that they use a security head, the special bit, screw head. All right. Now, let's see what the 5th edition has. It's the same as the 4th. All right. All right. Let's see. Length of wood screw should be about 1/8 less than the combined thickness of the boards being joined. You might want to be careful with that. You certainly don't want to bust out the back of your fastening. So you might need a little more than 1/8 of an inch. Your mileage will vary with that. Join with 1.5 to 2/3 of the screw length penetrating the base material. That's if you're going all the way through, if you're through threading. If you're blind threading it, you need to be careful. Fine thread screws are generally used for hardwoods, or coarse thread ones are used for softwoods. Bottom line is, holes for screws should be pre-drilled, especially if you're going into wood, and be equal to the base diameter of the threads. Some screws, such as self-tapping and drywall screws, are designed to tap corresponding female threads as they're driven, and that's true. For light gauge steel studding, these drywall screws will go through the drywall and go into the wood studs or the light gauge light metal cold form sheet studs. All right. This is a slotted head, this is a Phillips head, and there are different numbers of Phillips heads. There's different numbers of slot heads as far as sizes goes. You can go and drive yourself crazy and Google all the different screwdriver heads. All right, and they come in numbers, and it's the size of this. And if you're not careful, if you don't size the head of the driver, you'll strip out your screw. This is an Allen head. This is a square drive. And what they don't have here is a Torx. Everybody's seen the Torx. It's like this little star thing, right? Star thing. Torx. Okay. Torx. Okay. Torx. All right. Bolts. Bolts are threaded metal pins or rods. They come in different grades, sizes, strengths. Custom bolts are even greater than 30 inches. You get on YouTube and Google Portland Bolt Company, and you'll see them making some huge freaking bolts, threaded bolts for a power generation. I think it's a dam. Yeah, a dam. This is a lock nut or an aviation nut. It's got a nylon insert in here that bites into the threads. This is a castle nut. You see these on old axles sometimes, so you can put a cotter pin through here. When the castle nut goes on the bolt, there'll be a hole. There'll be a hole drilled through the bolt, and once that castle nut gets tight, then you'll set a cotter pin in there, and a cotter pin looks like that. It's split and it's a hole. This is what it looks like when you pull one out. You got to flatten it back with a hammer. But anyway, you set that through here, set the legs, and then the head sits in here. And it keeps the nut from backing out. All right, square head. This is a hexagonal head. This is a carriage bolt. And the reason it's called a carriage bolt is because that's what they made carriages out of. You drive this in, this little square box right here is driven into the wood. It bites in so that you can tighten this up. Okay, this is a cap nut. It's a captured end, and the problem with cap nuts, if you have more grip, in other words, more bolt left, as you're tightening down the cap nut, it'll blow the cap out and defeat the purpose of having a nice, pretty finish. You see a lot of cap nuts on, what was that fancy name they called light fixtures in the other chapter? Luminaries? Yeah, you'll see a lot of cap nuts used in light fixtures or luminaries. All right. Washers are perforated disc, and washers come in all kinds. There's load indicating washers. This is a load indicating washer. So when you're torquing that nut down, these little indentions here will flatten down, and that way you'll know that you put enough torque load on it. Okay. That gives you your attention on the bolt. All right. You have external tooth lock washers and a spring lock washer. You'll see a lot of external tooth lock washers on putting together machinery and stuff, and you'll also see spring washers, lock washers used. They both do the same thing. They grip against the panel, so the lock washer would go here, the bolt would come out, and the lock washer's in here, and then the nut sits over here, and when you torque it down, these legs flatten out and push against the nut to keep it from backing off. All right, enough of that. Miscellaneous fastening. Go to Home Depot or Lowe's, and you want to hang something in drywall, and you can't find your studs because you don't have a wall lot. Or where you want to hang the picture is between studs. All right, you don't have a choice. All right, everybody makes their own brand of fasteners to go through drywall, sheetrock, concrete, you name it. Everybody has their own claim to fame. This is referred to as a Molly bolt. It's an expansion bolt. Molly's a trademark. He puts that up here. All right. They can be used in are anchor bolts having a split casing that expands mechanically to engage the sides of a hole. You can drill it in masonry or concrete. If it's hollow, all right, you can actually go through the wall of the CMU if they're long enough. And when you tighten this down, it deforms like this and it grips from the back side. The problem with these, if you get the hole screwed up, the pre-drilled hole, then this moly bolt will not grip and it'll spin as it's tightening, and that can be a problem sometimes. Expansion shields or lead or plastic sleeves that you pre-drill, and you drive the lead sleeve in there, and then you can put a wood screw in there. There are better ones of these. They make a self-drilling nylon screw now that goes through sheetrock. You can go see them at Lowe's, Home Depot, or Amazon or whatever. Get good pictures of them, and they basically do the same thing. The plastic giant screw that goes through here, it self-tabs. And they come, each one of these comes with its own screw that's designed for this thing, and they'll screw in, and you can get these things to hold up to 50 pounds. They work really good. This is a toggle bolt. You got to drill a pretty good sized pre-drill hole on this. This gives you a tight fit in the wall as far as movement this way and this way. If this is installed properly, it's the same way. It gives you a good movement from either direction. All right. Same with this, but with a toggle bolt, you got to drill the hole so you can get the collapsed part of the toggle through the wall, through the sheetrock or the masonry wall, without splitting the CMU. That's assuming you can actually find the void in between the web of the CMU. And so this goes through, and then when you push it all the way through, it springs. It springs out. There's a spring in here, okay? And then you pull it back, and then you tighten it down, and you got to put a washer over here. I don't care what anybody says. You need a fender washer. And a fender washer is a bigger washer. If I have to use one of these in sheetrock, I'm going to use a fender washer. But this will theoretically grip the back of the surface. But you got to get it close to the surface when you start tightening it, or it's going to be spinning back in here. But as you can see, the hole is larger than the actual fastener shaft. So these things have a tendency to, under heavy load, to move down. And they end up probably most of the time resting on that. So anyway, let's see. That's enough of that. There are all kinds of expansion anchors that you can use. And I've used a lot of toggle bolts. I'm not down on them. You just got to be careful with them. I usually undersize drill the hole on a toggle bolt in sheetrock, and then I use the toggle back here to kind of shear the rest of the stuff out of the way without breaking it. You got to be careful though, and then you got to suck this up once it springs, and and then slowly start tightening this while you're pulling back on it, and then eventually tighten it up. But you do need a washer on this because the head's got nothing to attach to. All right, rivets. Oh my God, rivets. I've got a bunch of rivets I got to do on that aluminum boat. I got to flatten them back out. But I got a rivet gun and a molder. That's the backing piece of metal. Rivets are an old way of doing things. The Eiffel Tower was riveted. You got a lot of railroad bridges that were riveted because back in the day, the manufacturing of structural bolts was not perfected like it is today. All them bolts are made on automated machines. You can go to YouTube and look at how bolts are made, and you'll be amazed. They can kick thousands and thousands out an hour. But back in the day, the rivets were done. And I think the Empire State Building, most of that structural steel was riveted. It was riveted. It sure was. All right. So what you do with the regular structural rivet is you got to worry about your grip. Okay. This is your grip distance in here. All right. And you gotta forge, and these steel rivets are heated red hot, and then they're thrown with a tong and a catch bucket, and the catcher gets it, grabs it with tongs, throws it through here. Then the guy with the rivet gun, and he's got this steel backer in here that's the shape of the head, and he's pushing on this while the rivet gun is just beating the absolute way out of this thing, beating it down, and lots of noise, and you got to do it quick because you don't want this to cool. It's got to be red hot, and they just beat the way out of it. And the rivet gun is shaped for the head of the rivet, just like the mauler is, and then you end up with a finished grip. And the amount of banging you do on this thing would depend on how much force, all right, this rivet's putting on, because it's putting on some force. And it's gripping. That's why they call it the grip. It's gripping it. Okay. Now, he's got explosive rivets in here. Oh my God, I ain't ever seen anybody use explosive rivets, but they do have them, and they do have their purpose. They're used when a joint is accessible from only one side only. In other words, you can't get inside here. Okay, there's a tight space, so you can't have another person back in here with the backer maul, and they have an explosive fill shank that's detonated by striking the head with a hammer to expand the shank on the far side of the hole. You hit this with a hammer, kaboom, bam, and it blows, it explodes, and hopefully you get the grip you want. Okay. Now, aviation rivets are different than structural rivets, but since this is a building construction course, we won't talk about aviation rivets. I've got aviation style rivets in that boat. So I've got a special head, a special mauler, and I'll get my grandson, he's fixing to graduate from high school, come out here, and I'll put him on the mauler, and I'll have the rivet gun to tighten those rivets up. Riveting is still used in aviation a lot. Okay, I mean, commercial airplanes, a lot of them are glued. Here. So anyway, adhesives. All right, common types of adhesives. That brings us. That's a nice segue. Yeah. So when you're sitting on an airplane like 747, some of it's riveted, but some of it's glued together. So that ought to make you feel good. All right. Adhesives are used to secure surfaces of two materials together. Well, no kidding. All right. Strength. Adhesives are usually strongest in resisting tensile and shear stresses and weakest in resisting cleavage or splitting. Curing or setting time is important. All right. And curing in the right temperature. Okay. Setting temperature range is important. They'll set at room temperature while others require baking at elevated temperatures for curing. Method of bonding. Some adhesives bond on contact while others require clamping or higher pressure. Okay. Contact cement, you coat both pieces with contact cement. You let it dry to the touch, and then you better be sure how you want to stick it down, because once it touches, it's not going to release. And you have characteristics. Adhesives vary in their resistance to water, heat, sunlight, and chemicals, as well as their aging properties and outgassing properties. Okay. Now, so some of the oldest adhesives is fish glues, animal or fish glues. The American Indians would would take fish skins and boil them and turn them into a goo or glue. And then, especially the Indians up in the Oklahoma territory, they use Osage for the wood for their bows, and they would coat the front of their bow with that fish glue and glue leather on the bow, or snake skin or whatever, to give it more strength. So when they're bending it, these are primarily used for indoor use where temperature and humidity do not vary greatly. Yeah, the Indians didn't have epoxy. If they had epoxy, they'd be using like fiberglass and epoxy bows. But they'd actually probably be using compound bows now, crossbows, or a regular firearm. So anyway, I digress. White or polyvinyl glue sets quickly and it doesn't stain. Epoxy resins. Now I told y'all before, epoxy is a chemical. It's a chemical bond. Where a vinyl ester, like a vinyl ester, is a mechanical bond, where epoxy is a chemical bond, and it's a thermoset. Okay, so they're extremely strong and may be used to secure both porous and non-porous materials. They may dissolve some plastics, so you gotta be careful. Unlike other adhesives, epoxy glues will set at low temperatures and under wet conditions. Sometimes you check the manufacturer's recommendation. They will have a temperature range. They'll say, do not use this below a certain temperature, or be careful using it above a higher temperature because it sets too quickly. And once you get the epoxy mixed and you're trying to get the two pieces coated so you can clamp them together. All right. Resorcine resins are strong, waterproof, and durable for outdoor use, but they're flammable and their dark color may show through paint. All right. Some of these resorcine resins came as a powder, and you mixed it. And contact cement, we just talked about contact cement. Forms a bond on contact, therefore it doesn't require clamping. Well, it sort of does, but not like your other glues, not like the polyvinyl glues, which are your typical wood glues, and they're white or they're brown. They're not always white. And you can get waterproof wood glue now. The contact cement, it forms a bond on contact and therefore does not require clamping. It's generally used to secure large sheets of material such as plastic laminate. I talked to you about that when we talked about Formica. All right, and this is just a sprinkling of adhesives. The adhesive industry is a fast-growing still, and their technology and research is never-ending. The catalyst up here he's talking about, that's the hardener in your vinyl ester, your vinyl resins, or your epoxy resins. You got a hardener, and you have your resin. JB Weld is an epoxy paste that has a hardener. One of them's metal, the metal resin, and the other one is the hardener. Okay. All right. We're almost done with this chapter, and we're going to run it out. Paints and coatings. The purpose of a coating is to protect, preserve, or visually enhance the surface to which it's applied. The principal types of coatings are paints, stains, and varnishes. Paint is just that. It's a mixture of solid pigment suspended in some kind of liquid. Could be latex, could be oil, could be a mixture of a hardening agent like an epoxy. There's all kinds of sealers, base coats, and primers. Oil paints utilize a drying oil that oxidizes and hardens to form a tough elastic film. All right. Alkali paints, latex paints. You can spend your life researching paints. Okay. A pigment is a finely ground and soluble substance suspended in a liquid to impart color or opacity. All right. So what is a paint? It's got a pigment, that's your coloring, and a vehicle. It's a liquid which the pigment's dispersed. All right. Before being applied to a surface in order to control consistency, adhesion, gloss, and durability. The binder is the non-volatile part of the paint vehicle that bonds particles of pigment into the cohesive film during the drying process. That's the binder. All right. The solvent or thinner is the volatile part. That's the stuff that dries out. Okay. That ensures the desired consistency for application by brush, roller, or spray. So you got the vehicle, you got the pigment, you got the binder, and you got the solvent. All right. Epoxy paints have an epoxy resin as a binder for increased resistance to abrasion, corrosion, and chemicals. Rust inhibiting paints like Rust-Oleum and primers are specially formulated with anti-corrosive pigments to prevent or reduce the corrosion of metal surfaces. Fire retardant paints. You get a fire-rated paint you can paint your barbecue grill with, etc., etc. Are specially formulated with silicone, polyvinyl chloride, and other substances to reduce the flame spread of a combustible material, and it resists the heat. Okay. Luminescent coatings. All right. They are just what it says. When exposed to heat of a fire, they swell to form a thick insulating layer. That's not luminescent. God, I can't even read. Intumescent coatings. Oh my God, that looked like a L to me. All right, get my eyes checked. Sorry about that. Anyway, when these are a fire coating, the heat of a fire, they swell to form a thick insulating layer of inert foam that retards flame spread and combustion. And then you got heat-resistant paints, which are specially formulated with silicon resins to withstand high temperatures. That's what you'd paint your engine block with if you're building your hot rod or your barbecue grill, just like this fire retardant paints. Well, you really wouldn't use it on fire retardant. I misspoke up here again. To reduce the flame spread of a combustible material. You'd paint wood with a fire retardant paint. How's that? Okay. And then heat resistant paint. You paint your barbecue grill or your engine block. Varnishes. All right. Varnish is a liquid preparation consisting of resin dissolved in an oil. You got oil varnishes or an alcohol, spirit varnishes, that when spread and allowed to dry forms a hard, lustrous, usually transparent coating. Spar or marine varnish is a durable, weather-resistant varnish made from durable resins and linseed or tung oil. You got polyurethane varnishes, which is exceptionally hard, abrasive-resistant, and chemical-resistant varnish made from a plastic resin of the same name. It's a polyurethane resin. Lacquer refers to any various clear or colored synthetic coatings consisting of nitrocellulose or other cellulose derived dissolved in a solvent that dries by evaporation to form a high gloss film. Shellac. Shellac has an interesting history. It's a spirit varnish made by dissolving purified lac flakes in denatured alcohol. Stains. It's just what it is. It's a solution of dye or suspended pigment in a vehicle applied to penetrate and color a wood surface without obscuring the grain. It's not a paint, it's a stain. All right. It has a penetrating vehicle which permeates the wood surface, leaving a very thin film on the surface. Now, a water stain is a penetrating stain made by dissolving dye in a water vehicle. A spirit stain is a penetrating stain made by dissolving a dye in an alcohol or spirit vehicle. I do not like water stains. I have never had. It's just something about adding a water-based vehicle to wood, especially if it's fine wood. Let's say you're doing furniture. I just don't like it. Spirit, this stuff will dry out. It'll vaporize out. The spirits will, the alcohol. Pigmented or opaque stain is an oil stain containing pigments capable of obscuring the grain and texture of wood surface. It's a heavy pigmented, it's almost like a paint, I don't know why you'd use that, but they're available. The oil stain is made by dissolving dye or suspending pigment in a drying oil or oil varnish vehicle, like Wadco. Wadco wood stain, oil wood stain. I like Wadco products. Or tung oil. But Wadco products are really, really good. Wadco, it's an oil-based stain that goes on, does not mess up your finish, does not mess up the grain, won't lift the grain, and it soaks into the wood, and that oil dries out, and then you can go in and polish it, and it's works real well. All right, last page. Last page. All right, where are we at? We're at an hour and 4 minutes. No, an hour and 1 minute. Okay. Paints and coatings. All materials to receive paint or other coating, they must be properly prepared and primed to ensure adhesion of the coating to the surface and to maximize the life of the coating. In general, your mileage may vary. In general, surfaces should be dry and free of contaminants such as dirt, grease, moisture, mildew, oil, cooties, latents, you name it. Okay? The following are recommendations for various materials. These are recommendations from the book. Your mileage is going to vary. Whatever it is you're thinking about putting on or speccing for your project, you need to get with the paint manufacturer. You get their chemist, know how best to adhere their product, to guarantee it, to keep your color right, to keep the adhesion right, to keep the life cycle of that right. Use their recommendations. If they say you need to acid etch this brick, then you need to acid etch it. If the concrete masonry needs to have some thick base coat on it, then you do what they tell you. If it's a cast in place concrete surface, you do what they tell you. And they all need to be free. And some will need a primer, some will need several coats of a primer, or various primers, depending on what you're doing. Gypsum board should be clean and dry. Use a latex primer, sealer. Again, you go back to your paint manufacturer and you follow their directions. Plaster's another thing. All right, we all know gypsum board is porous. It'll suck that stuff up. So will plaster. All right, and you follow the recommendations. You know, whether you're painting or whether you're staining, you follow the manufacturer's recommendation. All right, follow the directions. All right, wood should be clean, dry. Yes. All right. Oil paint surfaces should be clean and dry. Old paint surfaces, I'm sorry. Old paint surfaces should be clean and dry and roughened by sanding or washing with a detergent solution. Depends on what kind of paint you're putting on it. If it's a lead-based paint, bad, and you're putting latex over that, it's not going to adhere. If you're putting a latex paint over a varnish surface, you may have to strip all that varnish off, or it's not going to adhere. Get with your paint manufacturer and tell them what you're doing. It's like you go to Sherwin-Williams and you buy paint because you're going to have a project. Then you tell them what is going on. Is it pre-painted? Is it a clean surface? Blah, 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 blah. They will tell you. Ferrous metal surfaces should be free of rust. This is a whole nother deal. Galvanized. You can paint galvanized. All right. Corrosion removed, solvent, chemical wash, prime with a zinc oxide or Portland cement paint. If weathered. Now, I don't know about the Portland cement paint. You get with the paint manufacturer. You tell them, I'm fixing to put this over galvanizing. Same with your ferrous metals. Okay. And it all depends. The old Navy method of painting those ships, they had several types of primers. One was an acid-based primer, one was a lead base, and then you had 2 primer coats and then 2 top coats. We had 2 primer coats, an intermediate coat, then the top coat of navy gray. In addition to the surface preparation and priming required, other considerations in the selection of a coating include compatibility. We already talked about that. The method of application. You're going to spray it, brush it, roll it. Some coatings don't like to be brushed. Some of them would rather be rolled or sprayed. What kind of spray? Is it an air sprayer or an airless sprayer? Conditions of use and the required resistance to water, heat, and sunlight. All right. Sunlight. UV chalking. Some paints don't like it, even though they say they have a UV inhibitor in it. All right. The possible emission of harmful VOCs. That's volatile organic compounds. VOC. If you're using epoxy paints or epoxy-based paints or oil paints and they're outgassing and they're drying, they may emit a VOC. And if you're doing it inside, you're going to want ventilation and proper PPE. Correct? Correct. I'm glad we agree. All right, that finishes chapter 12. That's the last official chapter of this book. We're at 1 hour and 6 minutes. Now, I've said before, this appendix, and we're not going to go through the appendix, but the appendix of this book, and you need to keep this book throughout your entire design career, it has human dimensions. It has all the ADA guidelines, and you get your current ADA guidelines from the government. You just go to ADA guidelines, and you'll get ada.gov. All right. It has some furniture dimensions. Your mileage will vary. Then it has a big list of building live loads. Guess what? You better check your building code. All right. This is a good rule of thumb for starting out. Okay. But don't be surprised if your live loads, your structural engineer comes back and says, "Wait a minute, Bucko. Weights of materials. There's good rules of thumb on that in there." There's some metric conversion factors, as if you can't go to Google and say metric to feet or metric to inches or meters to inches, right? Means of egress, how to get in and out. Fire-rated construction. There's some really neat fire-rated construction details in here, including like water enclosed columns, like at the Centre de Pompidou in Paris, France. All those exterior round columns have water in them. And that's for their fire suppression system. So all that exposed steel is not going to get damaged by any fire. They'll hit the pumps, and the water cascades down the outside of those round columns in a nice water feature and keeps it cool. All right. But the fire loading in the Centre de Pompidou is not all that great. It's not like a warehouse, okay? It's a freaking art museum. Acoustics. It's sound control. It's got all your graphic material symbols for drafting, all of them. It has your CSI master format again, and it's got the uni format. And then it has LED green building rating system and your professional trade associations, some of them. So I apologize about that bloody dog. But for the trade associations, I've given you a bunch of trade associations, but they change and change names and all that other good stuff. See, here's a water, liquid fill columns, spray on fireproofing, box with multiple layers of gypsum board, clay or shell brick, blah, blah. All right. More fire rate instruction, sound acoustic, sound control. Let's see. Acoustic double stud walls. Double studding on the walls for sound non-transmission, and these are graphic materials for drafting. And here's CSI format. All right. I just had to pause it and take care of that dog. Master format, CSI master format. There's the uni format. There's rating systems and professional trade associations. Now, I make no guarantee that these contacts are still good. Google them. American Institute of Architects, we know is still good. But you may find some of this useful. You may find it not. Who knows? Anyway, all right, that ends the walk through this book. Wasn't that fun? Okay. All right, we're done with this.